We are starting out with chapter 3 today. So again, if you have not started working on chapter 2, and I see that those of you who have started working on chapter 2, you are just kind of getting started with 2.1. So please remember that chapter 2 assignments are due on this coming Monday, that's the 17th, at 2:30 p.m. So right before class starts on Monday. So please make sure you do not, fall behind. Because again, as you will recall, um, you must have 90% attendance and 90% homework grade, right? To be able to take your midterm and final exams. Alrighty, so let's go ahead and get started, like I said, with chapter 3. So chapter 3, you will see we are actually focusing on section 3.1 here, which is where we will talk about measures of central tendency. So that basically means we are going to be looking at how to calculate averages. So we will be looking at 4 different calculations. We will be talking about mean, median, mode, and mid-range. So 4 different ways that we can calculate. And of course, then we will see, how this can kind of help us understand the data a little bit better. So here we're just kind of talking about some examples. I hope you guys can see that screen properly. Danny, again, please make sure your camera is turned on. So when we're talking about a measure of central tendency, we are obviously talking about a numerical value, which is going to be your average or basically what your typical data value might be. So when we hear the word average, we could be talking about the average miles per gallon of gasoline. They're talking about a 2016 Chevrolet Corvette Z06, which is about 29 miles per gallon for highway driving, which is actually not bad for a Corvette. According to the US Census Bureau, the national average commute time to work in 2013 was 25.4 minutes. Same thing, next example, according to the US Census Bureau, the average household income in 2014 was 53,657. And then the last one, the average American woman is 5 feet 4 inches tall and weighs 142 pounds. So you can see in all of these examples, we are using that terminology of average. But again, keep in mind, they may not all be based on the same calculation that we are talking about here, because like I said, there are 4 different ways that we can calculate an average. Now, your textbook is talking about mean, median, mode, but as I mentioned, we will also be discussing mid-range, which is another calculation for, finding an average. So let's start out with our arithmetic mean, which is basically what, we normally call as just a mean also. So you can call it arithmetic mean, or in most textbooks, we call it as just a mean. So this is where you take all of the values that you have in your raw data for your variable, and you add them together, and you divide it by the number of observations. So how many data values did we have? We divided by that number. So the population arithmetic mean, and this is where, guys, to differentiate between population and sample, we actually use Greek letters when we are talking about the population calculations, and we will use Roman letters like, our A, B, and C's for samples. So you will see here when we're talking about the population arithmetic mean, we are talking about mu, and you can see that pronunciation there. So that is the letter mu, and this is used when you are calculating the arithmetic mean for the population. So remember, for terminology's sake that we had talked about in chapter 1, the population mean is what we would call as a parameter. For your sample arithmetic mean, you will see we're using the x variable, but we are putting a bar on top of the x, and that is to show that we're talking about an average over here, because we can use the letter x as a variable for any unknown quantity, right? So to avoid that confusion that we're just looking at the variable x, we end up putting that bar on top of the x, and that tells us we're looking at a sample arithmetic mean. And of course, remember your sample mean as a terminology is what we call as a statistic. So population mean is a parameter, sample mean is a statistic. And then you can kind of see the basic definition over here of how we calculate a arithmetic mean. Cameron, did you have a question? Oh, okay. So you will see mu represents the population mean. You are taking all of your variables, all of your data values for the variable and dividing it by how many total variables we have. So you divide it by n. And again, notice here, guys, we're using a capital N because that represents the population size. So the capital N is our population size. So add up all those variable values, divide by n, and you get your arithmetic mean. Now, when we are talking about a sample mean, right? So you will see here for the sample mean, we are using the X bar notation, but the formula looks pretty much the same. You are adding up all the data values, but this time we are dividing by a small letter n, right? So we've got the sample size, which is the small letter n, and again, add up the total, divide by how many data values you have, and we are good to go. So let's go ahead and take a look at some examples here. I guess the other thing you should recognize, I've already talked about the capital N representing population size, small letter N representing the sample size. We're also seeing this summation symbol, which is the capital letter sigma, but we call it summation because, you know, we're using it to add up. This is used to tell us that we are adding up all the terms. So when you see summation of x sub I, we are basically saying add up all the x values which represent your data to get, you know, our sample mean or population mean, depending on what you are doing there. So let's take a look at this example here, guys. We're computing a population mean and sample mean based on first exam scores of 10 students enrolled in an intro to statistics course. And the 10 students are your population. So to talk about the population mean, you will basically see here, we're adding up all the test scores and dividing by the number of individuals in our population. So you can see we have a total of their test scores over here. So that total comes out to be 790. And then they are telling us our population size is 10. So you are, of course, taking that total of 790 and dividing it by 10, which tells us the average score of the students is going to be 79. Now, of course, you will see there are some students on the lower end, you know, they had 62, 68 as their exam grade. And then there's a couple students who are sort of at the higher end. You've got the 90 here, 94, 88. So, you know, just taking a mix of all of those, we get an average of 79, which, you know, sort of kind of is somewhere in the center. Now, so they're just kind of talking about rounding rules over here. And, you know, again, it will depend on the example you are looking at. But basically, they are saying we will agree to round the mean to one more decimal place than what is in your raw data. So if you have, you know, 2 decimal places in your raw data, then you round the mean one more, which means you will go to 3 decimal places in your rounding for the mean. So just a rule to kind of remember as you guys are going through your homework on chapter 3. Now, part B here was asking us to find the simple random sample of 4 students. So this time keeping a population size of 4 students. So they're saying, okay, you can use technology to find a random number generator. So you can use TI-84 or like we talked about before, random.org. And looks like the 4 students they picked are Jennifer, who had a score of 62, Juan at 88, Ryan, not sure how to say that, 77, and Dave had a score of 68. So you can see we take those 4 scores, add them together for a total of 295. And then since we're only talking about a population of 4 students here, we divide by 4, and you can see this is coming out to be 73 0.8. So this is kind of the rounding rule they were talking about. Since our raw data is whole numbers over here, in your rounding, you go 1 decimal place more than your raw data. So since we didn't have any decimal places in the raw data, we went 1 extra decimal place, and that's why we're rounding this to 73.8 and not, all the way up to 74. So 1 decimal place is what we are rounding it to. And then they're kind of showing you graphically what this would end up looking like. So you can see we are looking at a histogram of these scores for the 10 students in class. And you will see our population mean had been 79. And you can see 79 does kind of seem to be in the center of our data set here, isn't it? So we're kind of right over here on 79. And yeah, that kind of seems halfway through. So that's not too bad. So that's your mean calculation. Did anybody have any questions on the mean? And we'll look at an example where you guys will get to practice that, but just for now, any questions? No? Okay. So let's move on to the next calculation for an average. And here, we're talking about the median. Now, median is actually based more on the placing, the position of the data. So if you look at the definition over here, we're basically saying to compute the median of a set of data, of course, our data must be quantitative, so it's got to be a numerical data, right? So the median of a variable is the value that lies in the middle of the data when arranged in ascending order, which means you go from the smallest to the largest data value. And we are using the letter capital M to represent the median. So remember, for the mean, we used X with a bar on top of it. For median, we're using the capital letter M. So one thing to remember is you want to arrange your data in ascending order. So go from smallest to largest and then determine how many total data values do we have. So what is our size of the data value? Then determine the observation in the middle of the data set. So think about the word median, because we use the word median for highways, right? When we have that little island looking thing between the two flows of traffic. So if you're going east and west, we'll have a median, which can sometimes be this concrete block, or sometimes it can be just greenery, right? Growing in the middle of the highway. So we call that in the median because it's literally halfway between the highway, because the left-hand side, will be the traffic going the other direction, and the right-hand side is, of course, the direction that we are going in. So that's exactly what a median is. It's the halfway point between your data set in this example. So that's why arranging the data in order is very important from smallest to largest. So what we do is we can actually use this position formula over here. So once you figure out how many total data values you have in your set, they're calling it the number of observations, you add 1 to it and you divide by 2, and that actually tells you the position of where you will find your median in your entire data set. So they're talking about if you have odd number of observations, then you are just going to be using this n plus 1 divided by 2. But if you have an even number of observations, then actually that is going to mean you're going to have to take the 2 centermost values, add them together and divide by 2. So you will actually have to find the mean of the 2 centermost or middle observations in your data set. So they are saying in this case, you can do n divided by 2, and then n divided by 2 plus 1 to find your 2 positions. But I actually just keep one formula, so I don't have to remember 2 separate ones. So I actually use this same formula for both odd and even, and I'll show you how I use it. So let's take a look at this example here. Now, this one is telling you that it does have odd number of observations. We're talking about the table here representing the length in seconds of a random sample of songs released in the 1970s, and they want us to find the median length of the song. So let's take a look at this guy here. So remember, we're talking about the length of songs, and this is in seconds. So, we're saying this song, Sister Golden Hair, is 201 seconds long. Looks like Free Bird, is 284 seconds long. That seems to be the longest one. Staying Alive is 222 seconds long. So, of course, we need to first arrange this. I don't know if you guys can see the table with the solution. But if you can't, let me know. So you can see we start by arranging this from smallest to the largest value. So we have 179 seconds. It keeps growing till we get to that 284 seconds. So you will notice these are 9 total observations or 9 total songs that we are looking at here. So using this position formula, we have 9 for the n value. So that's going to be 9 plus 1, which is 10. 10 divided by 2, of course, gives you 5. So basically, the idea is then you go ahead and find the 5th position. Now, you can do the 5th position from the right-hand side of your data set or from the left-hand side. It doesn't matter. So we can say, okay, this is 1, 2, 3, 4. This is our 5th position. You can come from the other direction, 1, 2, 3, 4, and you've got the 5th position here again. So you will see the median in this case is going to be 217. So that's how you calculate the median or find the median when you have odd number of observations. But what if you have even number of observations? Then how would you go ahead and find the median in that case? So let's take a look at the even number of observations here. Let me go ahead and clear out my writing. All right. So this is talking about the table 1 that we had seen before. That was, we had 10 students whose exam scores we were looking at for the first exam. So now using that same example, we're arranging their grades from smallest to largest. So you can see the smallest score a student had was 62. The highest one they had was 94. Now in this case, we have a total of 10 number of observations because there are 10 students whose grades we are looking at. So of course, if we did the n plus 1 formula like before, n plus 1 divided by 2, of course, as you can see, that would be 10 plus 1 divided by 2, which is 11 divided by 2. And then, of course, 11 divided by 2 comes out to be 5.5. So 5.5, you can see, is of course going to be a value between 5 and 6. So that means you are looking at the 5th and 6th position to find your median. So if we go, okay, this is 1, 2, 3, 4. This is going to be my 5th and 6th position. Going from the other direction, same thing, 1, 2, 3, 4. And then you can see this will be our 5th and 6th position. So those are the two numbers that we are going to have to find the average or the mean for, right? So you will take 77 plus 82 divided by 2, and you can see that median comes out to be 79.5. So this is how you can calculate the median by using just one single formula, n plus 1 divided by 2. Now you can see your textbook talks about you take n divided by 2. So that's 10 divided by 2, which gives you the 5th position, which was again this guy here. N divided by 2, which is still 5. And then you add 1 to it. So 5 plus 1 gives you the 6th position, which would of course be this guy over here. So instead of, remembering, okay, we have, come on, buddy. Sorry, my pen is just being a little finicky today. All right, so they are saying for odd number of observations, you need to remember this formula, and for even number of observations, you need to remember this formula. So what I am saying is just remember one single formula and it works for both odd and even. So, of course, what I would tell you guys is try it out and see which one makes more sense to you and which one you're comfortable using. For me, it's just easier to remember one formula instead of remembering, 2 or 3 different formulas if you know how to work it in different situations. So that's what I was talking about. You just do n plus 1 like I showed you here. 10 plus 1 is 11. 11 divided by 2 is 5.5. 5.5 falls between 5 and 6. So we know we're looking at the 5th and 6th position. So that way we don't have to worry about, you know, these formulas here. So that's kind of what I'm talking about. So like I said, practice. And of course, if you have any questions, you let me know. So this is talking about finding the median over here. Now, this example, you will see they are talking about finding mean and median using technology, using StatCrunch, TI 8385, sorry, 84 plus calculators, Minitab, Excel, and I'll let you guys, look through the examples yourself, because when we do the example in class, I'll talk about, how I can show you using Google Sheets or Excel to do that. Something just to keep in mind, they are talking about a numerical summary of data is said to be resistant if extreme values, which can be very large or very small, relative to the data does not affect its value substantially. So when we're talking about not affecting its value substantially, is basically, if you look at this example over here, and even though we're not using technology, this one is just basically showing you Yolanda wants to know how much time she typically spends on her cell phone. She goes to the phone's website and records the call length for a random sample of 12 calls that she has made. So you can see in table 3 what her call lengths are. And most of them are single digits, except that one, right, which is 48. So you will see when they talk about calculating the mean for Yolanda came out to be 7.25, whereas the median came out to be 3.5. Now, if you look at her data, and let's for now ignore that 48. You've got 1, 2, 3, 7, 4, 5, 3, 3, 4, 1, and 6. And you can see they've done a dot plot over here. So you can see how most of her data is right over here. And then you have that 148 value, which goes to that extreme right. So 7.25 is obviously going to be somewhere after that dot for 7, right? Somewhere next to it. So that mean does not actually even seem like it should be the mean, because most of your data is here. But that's what happens with mean, guys, because remember, we take all the data values, add them together, and then divide by how many total data values we have. So what that 48 is doing, it's pulling that mean further to the right, and that's why that mean is coming out to be at 7.25, because that 48 is kind of stretching it to the right hand side. But if you look at the median of 350 makes sense, because that's kind of right here in the center of this data over here. So the median is what we would call as a resistant data value, because that 48 is not affecting its position, right? It's not pulling it to the right, like how the mean is being pulled to the right. The median is resistant to those extreme values. So that's basically what we're talking about here in terms of numerical data is said to be resistant if extreme values do not affect its position. Here you will see we're just talking about how, with the distribution shape, your relation between the mean and the median can be changed. So remember, we had talked about uniform, bell-shaped, skewed to the right, skewed to the left shapes of distributions. Yesterday, you guys are having too much fun with those reactions, I can see there. Alrighty, guys, so you will see when we are looking at a symmetric shape of a distribution, your mean and your median will be equal to one another. So in a symmetric shape of a distribution, mean is equal to the median. When your data is skewed left, which means you have the tail on the left-hand side, you will see the mean is going to be on the left, which means the mean is going to be smaller than the median, because your median is going to be on the right. So the value of the mean is going to be smaller than the value of the median. When your data is skewed right, which means your tail is going to be on the right-hand side, this is where your mean will also be on the right, which means the value of the mean is going to be greater than the value of the median. Okay, so it's only in symmetric where your mean, median, and honestly, even the mode will be all equal to one another. But when it's skewed left and skewed right, you can see there's going to be a difference between the mean and the median. And again, guys, I keep saying this, reading the textbook will really help you get some of those minor nuances, which will really come in handy over here. So this example here is talking about describing the shape of the distribution. So this table here is giving us the birth weights, that's of course in pounds, for 50 randomly sampled babies. So you can see they are using technology here to find the mean and the median. So you can see with the birth weights, the mean, which is the X bar, is coming out to be 7.49. And the median, which is the center position, is coming out to be 7.35. So pretty close to each other, but obviously not equal to each other. So they're asking us to describe the shape of the distribution. So, of course, they are saying this is going to be bell-shaped. We have further evidence of the shape because we know that the two values, right? The mean and the median are close to each other. So they're not equal, but they are fairly close to one another. And that's a good argument that we can make, on the shape of the distribution. And then the last question they were asking us is, sorry, I read that question and it completely flew out of my brain. Which measure of central tendency better describes the average birth weight? So which might be a better measure of central tendency over here? So you can see the histogram we have over here, guys, and you will see how we have the median, which was at 7.35, and we have the mean, which was at 7.49. So you can see they're just slightly away from each other, but, obviously close enough. And if you will see the shape, now it's not going to be that beautiful, perfect bell shape, that we see on, like a normal distribution. But obviously you can see we have the higher concentration of values in the center, and then it's kind of tapering towards the side. So we can definitely make the argument that this is a bell-shaped distribution. Danny, I don't know what happened to your camera, but it's pointing to the ceiling now there. So in this case, because both your mean and median values are close to each other, guys, we can actually say you can use the mean as the measure of central tendency over here, because again, those two values are not too far. So one is technically not better than the other. And so in that case, you can go ahead and use the mean as, they're calling it the balancing point of your histogram. So we would go ahead and use that as our measure for central tendency. Okay, any questions so far on finding the median and calculating the mean? Okay, so the last calculation that your textbook is talking about is the mode. And the mode, what you want to think about the mode is, like I was using the terminology before, what is the most typical data value or the most typical characteristic, depending on what you're looking at, or as the definition here is talking about, the mode can be the most frequent observation of the variable that occurs in the data set. So in other words, which value has the highest frequency? So which is the most frequent observation, that becomes your mode. Now your mode can be one, you can have just a single value as the mode. It can be more than one, or they may not be a single value that occurs more than one. So you can actually have no mode in your data set. It may say, hey, you know what? Nothing repeated, so we don't have a mode in this data set. So you will look at these examples over here. This one, of course, you can see there's a bunch of zeros. that are repeating, then there's ones, there's a 2 and a 3. So in this case, and this is talking about the data representing the number of O-ring failures on the shuttle Columbia for its 17th flight, for its 17 flights prior to, the one where it didn't make. So you can see how we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. We have 4 ones, just 1, 2, and 1, 3, right? So you will see zeros occurs the most number of times. So your mode is going to be that number 0 because it has the most frequency of 11. So that becomes your mode. And literally that's what mode is. Which data value occurs the most frequently? This one here, again, we're going back to those original 10 students who had, their first exam score recorded. So you can see in this case, none of the values occur more than one. So there is actually no mode because none of the values are repeating. So if there's no value repeating, there is no mode. So you can see you can have one mode, you can have two modes, which is what we would call as a bimodal. So there may be like two values that occur most often. And in that case, you would end up with a bimodal data set. And if you have more than two, you have three modes or more, then we would basically just use the term multimodal or multimodal, however you want to say that. So you can see how just generally those graphs might look like if you have one mode, two modes, and then, of course, more than two. One thing that I did want to point out, the mode can actually be calculated for quantitative and qualitative data. So the mode does not only have to be for numerical values, it can be for qualitative values that, describe some kind of characteristic, because you will see in this example, we had looked at this example in the last chapter where we're talking about the location of injuries that required rehabilitation by a physical therapist. So where was that injury located at? And you can see this is that same table we had looked at before. So in this case, and I'm sure it may be hard to remember, but we had seen that the back was the largest number of location that appeared in this data set. There were 12 instances. So if, we did that frequency distribution table, you would end up with 12 as the frequency for back. So in this case, the mode location of injury would become the back. That would be your mode in this example over here. So you can see a quick summary of how we calculate the mean, based on population or mean, median, sorry, not population, population and sample. So how you calculate the mean based on population and sample. Median is going to be the same, doesn't matter if you're doing population or sample, and same thing for mode, it's going to be the same. And then you can kind of see when these calculations can be used. So this may not be a bad table over here to kind of save, because when you do take the exam, guys, you will have access to bring notes with you. So this will be something I would recommend to kind of save so that you can have it, as a reference when you're taking the exam. I think this is a pretty neat table over here. And then, as I always point out, you can see they do give you instructions on how you can find these calculations using technology. So what I would like us to do is take a look at one of our own examples. And I'm going to leave it on this page for now till I go and give you access to the example we will be working on. All righty. And again, in the meantime, if you have any questions on mean median mode, let me know and I'll show you mid-range, which is going to be, as I was mentioning before, another one of our calculations that we will be using. Right, there we go. All right, guys. So in chat, I am going to share the link with you for the example that we will be working on. So if you go ahead and click on that link that I just posted in chat, you should be able to see it's for Google Docs. And I actually need to change that to editor so you guys have access to. So let's see, it looks like there are 4 of you today. Omar, I'm not seeing you. I'm not sure where you disappeared to. Oh, there you are. All right, so let's do this in group number 1. I'm going to split you guys into 2 groups. We can do Aaron and Omar. You guys can work together on group number 1, and that would leave Cameron and Danny in group number 2. So I will actually show you how to use these built-in functions. So if you will actually follow me to the example page for now, so I can show you how to use the different examples, and then you can do your own calculations for the samples. So you will see, since we want to do a comparison between the population and the samples, you have to find all ages, which is, I guess I didn't really set up the data here. So the data here actually represents the ages of the US presidents at the time of their inauguration. So you can see we're starting out with George Washington. And I'm on the original data page here, guys, which you should hopefully be able to see. So you can see George Washington was 57 at the age of his inauguration, and we go down through all the different presidents. And this data set actually only went up to, I think it was just up to Clinton or George W. Bush. I don't remember, but I added the last 3 presidents. Now, the one thing you should notice here is President Garfield. Was it Garfield? It was one of those G presidents. Anyway, there is, I'm not seeing the name I'm wanting to look at, but one of the presidents, like President Trump, actually had 2 terms, but they were non-consecutive terms. So they were not back to back, right? So you will see what we do then in those cases is we actually only use their age at the time of their first inauguration. So that's why President Trump is only listed once, because this is the age he was at when he became the president in 2016. And so we're not repeating his age, for the current administration. So that's just something I wanted you to keep in mind as you're looking at this. So we're not using any of the other values from this table. We're only looking at their ages. So we basically have a total of 45 ages in here, because again, we're not doing the repetition of them becoming presidents a second time if they had a non-consecutive term. So the N value here, guys, is to just count how many data values do we have in our data set. Now, of course, we could go down the line and say, okay, there's 1, 2, 3, 4, 5, and keep going, right? But the other and the easier method would be to use the count function. So you will see I'm on the example page now. We have the count function that will actually count how many data values you have. So you can say, okay, equal to, I'm going to type count, and then all you have to do is select the cells where your data is going to be. So starting at the age 57, we select it and go down till you get to the last age in that data set, which will of course be for President Biden at 78. So you will see once I hit enter, that comes out to be an age, a total of 45 ages. So we have a total of 45 ages over here, and the count function helps you calculate that. So I have that same N value over here because you guys will be coming up with your sample sizes here, and then you want to make sure you have the accurate number of sample sizes, but we'll get to that part in a minute. Now, how do we calculate the mean? Remember, the mean was where you take the total of all the ages and then divide by how many ages you have, which is 45. So if we had to do that calculation, we could say, okay, I want to add up all the 45 ages of these precedents here so we can use the sum function. And same thing, I would go ahead and select all of these ages from our table. So you can see I go ahead and select all of these ages, and you can see that total comes out to be 2,498. And then if I took this total of 2,498 and divided by the total number of ages we have, which remember is 45, you can see this is what your mean is coming out to be, 55.511111 repeating, right? Now, instead of doing a two-step process, you will see that we actually have, again, a built-in function called average in Excel or Google Sheets. So instead of using the two-step process, I'm just going to use the average function, and I did not spell that right. So you can see we have that average function built in. So same thing, type in equal to and the word average, and then select all of those 45 ages for our precedents. And you will see it gives us the same mean that we got over here. Now, I have this set up to round to 1 decimal place, but if you make more decimal places, you will see the two answers will match over here. But remember our rounding rule. You do 1 decimal place more than what you had in your raw data, and our raw data is whole number, so you only want to round this up to the 10th 1 decimal place. Now, if we had to calculate the median, remember the traditional way of calculating the median? And I'm just going to open up a blank sheet over here, guys. Is we take all those ages, and remember we put it in order from smallest to largest. If you remember, we had talked about how we paste this on a blank sheet and then we sort it. So go to the top of the column and hit sort from A to Z. And this will help us sort it from smallest to largest. So you can see the smallest age is 42. Of course, the oldest was President Biden at 78. Now we know our N value is 45. Remember the position formula for median was N, N plus 1 divided by 2. Well, then that would, of course, translate to 45 plus 1 divided by 2. And we know 45 plus 1 is 46. So that would be 46 divided by 2. And of course, 46 divided by 2 will come out to be 23. So this is the position. You are looking at the 23rd position to find your median. So what will our median be? Oh, I cannot spell today, can I? So this is the thing I like, because we are using a blank sheet and we started out from the first cell where our first age is going to be. You literally just have to go down to the 23rd cell and it will show you which age is going to be our median. So you can see for cell number 23 or the 23rd position, our age is 55. So the median is going to be 55. So this would be, doing it the way your textbook is talking about, right? Now, if we come back to the example worksheet, you will see for median, we also have a built-in function called median. So you can, again, go in here and you can type, okay, equal to median. And same thing, just select your raw data set from 57 for George Washington all the way down to Biden for 78. And you can see, guys, we got that same age of 55. So instead of doing it the longer way, we can use the built-in function. And again, I'm showing you this so that when you are working through homework in my stat lab, you can use Google Sheets or Excel to do these calculations. You don't have to do them, by formula or by hand, because this would make it quicker and faster, right? And easier, honestly, than trying to do those long formulas. And trust me, those formulas are going to get pretty bad and lengthy as we keep moving forward in the chapters. Okay, any questions so far on finding the mean and median using Google Sheets? So that's the average function, and that's the median function to do that. Okay, now mode. Remember, mode is which number occurs the most often. So I'm actually going to go to that sheet 4 for a minute. Now, remember, you can do a frequency distribution table here, right? We can see how many times does age 42 repeat, how many times does age 43 repeat, 46, 47, 48. But why? Because it's going to take us a long time to convert this into a frequency distribution table. So here's something I do want to show you. For the mode function, when you go equal to and type mode, you will see 3 different functions show up. You have mode dot multiple. So, this is where if you have more than one mode, or mode dot single. So you will see in the instructions over here, I have said you can use the mode function, mode dot single or mode dot multiple, depending on if you have a single or a multiple mode. So what I do, guys, by default, because I don't know if my set has one mode or more, I always by default use mode dot multiple. But there's just one slight thing you have to be careful about when you're using mode dot multiple. So I'm going to go ahead and select all of my ages again, like we did before. And you will notice that when it types in its answer, it actually gives you the answer vertically. So I have 51 and 54. So actually, those are the 2 ages that are repeating the most often. And you can see that on sheet 4, because you will see age 51 repeats 5 times, and you will see age 54 also repeats 5 times. So that's why they are the maximum mode, right? Because 51 has 5 appearances, 54 also has 5 appearances. So they are your mode. So what I would do in here in my cell, then I would do 51, comma, 54. That's how I would type it in. So you just have to be careful that your mode dot multiple gives it vertically downward. So you may have to do like scratch work on the side and then enter your answers in, because if I did it right over here, then it would take up the space where I'm going to enter my mid-range. And I don't want that, right? Because that's where I want to enter. So that's why I did it to the side, and then I just typed in my answers over here instead of entering the formula over here. So these were the 3 calculation, guys, that we did from the textbook. But now you will notice there is another calculation over here called mid-range, which your textbook doesn't talk about, but it is a measure of central tendency. So let me talk about how we calculate the mid-range. So the mid-range calculation is where you take your highest data value and to that you add your lowest data value. So you get that total from highest to lowest, and then literally you divide it by 2 because we're taking 2 numbers, we're adding them together. So get that total and then divide it by 2, and that will give you your mid-range. So basically you will see there is not a mid-range function that is built in Google Sheets or Excel. So what I do is you will see here for mid-range, I actually use the maximum and the minimum functions to help us find the highest data value and the lowest data value. And then you can add those together and then divide by 2. So let me show you that on the side over here. So again, we're going to use the maximum function. So that's max. And then again, go ahead and select all of your ages. And you can see the maximum age will, of course, be no surprise for President Biden, which is 78. The youngest age, that will be using the minimum function. So you can see by using the minimum function, which I believe is 42 when we set our table in order, when we did the ascending order, is 42. So you can see that on sheet 4, our youngest age was 42 when we set that in order. And of course, like I said, the oldest was 78. So you can do it that way also. Or you can just use the maximum and minimum function like I showed you here. And then, like I said, add those two ages together. And I'm going to do this in parentheses. So, or actually, I can do it right here in our mid-range formula. So I'm going to do this in parentheses. I'm going to add the 78 and the 42. And then, of course, I'm going to divide it by 2. And you will see our mid-range comes out to be 60. Now you have to think about, which age seems more appropriate over here. Which calculation is mean, median, mode, or mid-range more important? So remember how we talked about how the mean can get affected if you have a very large value, right? So the very large value will tend to pull your mean towards that. Or if you have a very small value, like all of your data set is here, but then you have a very small value. So the same thing, that small value will try and pull your median towards the smaller side. So you have to be careful about that. Median, of course, gives you the centermost position. Mode tells you which is occurring most often, so which has the highest frequency. Now, mid-range, we have to be careful about because it's ignoring everything in the middle, right? It's only taking the smallest data value, the highest data value, but it's ignoring everything in the middle. So in this case, I would say either the mean or the median is probably the best measurement of central tendency to go with. And since both mean and median are pretty close to each other, you can use the mean as the measure of central tendency. All right, guys, questions about these 4 calculations and how to use them to do in Google Sheets, since that's what we're focusing on. Okay, so I'm going to wait on the range and standard deviation because we have not talked about that yet. So we'll do that next time. So what I would like you guys to do right now is you will see we have to create some samples over here. So what I would recommend you guys to do is go to random.org because that's, a great random number generator. And again, for this, I would go down to integer generator down here. Instead of using this guy on the top right corner of the web page. So go down to numbers and then use the integer generator. Now you want to come up with 10 ages. So I would say, okay, I want to generate 10 random numbers and we're only going from 1 to 45 because remember, we only have a total of 45 ages for these precedents. And you can put it in 5 columns, 1 column, it doesn't matter. I always just leave it in 5. So if I do get numbers, these are the positions, guys. Remember, these are not ages because we're not going to have a precedent who is 3 years old. So remember, these are the positions. So I'm just going to copy these over to my spreadsheet. So that way, I don't have to keep coming back to this page. And I'm just going to post it somewhere on the side. I guess I can do it right here under the blue tables. And I'm just going to go ahead and post it so that way I know where these ages are going to be. So remember, the third age is going to be 1, 2, 3. So you can say the third age is actually a precedent who was 57 years old. So what I would tell you, the easiest way to do this is because the first 2 cells over here are being, used by wordings like your name and all ages, just add 2 to each one of these numbers. So if you say 3, 3 plus 2 is 5, and you can see at 5 is where I had my third age, right? If you take 25 and add 2 to it, well, 25 plus 2 is 27, so that will be the age of 42. So that's what I would put here. 43 plus 2 would, of course, be 45. So the age on the 45th cell was for President Obama, who was 47 years old. So I would put 47 here. The next one is 27. So 27 plus 2 is 29, which would put us at the age of 56. So we will do 56 next. And then let's see, we are at 45. So again, 45 plus 2 is 47. So that is President Biden's age at 78. I'll go ahead and put that in there. And you can see basically repeat that process, right? 14 plus 2 is 16, that's 48. 25 plus 2, 27 is 42. And we've actually already used that, so we're definitely going to have a mode in this case. 35 plus 2 is 37, which is age of 55. Let's see, 21 plus 2 is 23. That's an age of 51. And the last one is going to be 30. So 30 plus 2 is 32. And that's the age of 54. So that's how you actually will come up with the 10 random samples for your ages. Now, since you guys are working in groups of 2, group 1 was Aaron and Omar. You guys can do the first 5 for Aaron and the last 5 for Omar, or however you guys want to do it. I've had students go alternate. So some will take the odd number columns and some will take the even number columns. And then, of course, same thing for group 2, which is Cameron and Danny. You guys can also take 5 and 5 samples each. So again, just create however you want to break those columns up. You can do the first 5, last 5, alternate them, or however you want to do. So the first thing you want to do is come up with those random 10 ages. And like I showed you, go to random.org, do a random number generator from 1 through 45, 10 times, so that you can get those 10 numbers. And then remember, these are the places, the position, and then you need to go through the table and find the position. So remember, to each one of these numbers, you are basically adding 2. So that's how you find out which cell you are going to be looking at. Okay, so that's how you will find your ages. And then once you have that, you can then do the calculation of mean, median, mode, and mid-range, like how I showed you for all the ages. If you get stuck on anything, you need my help, you can unmute yourself, or you can put it in chat, whatever you're comfortable with. So just remember, to each of these positions, you are adding 2, so that you just have to go look at the cell and you can figure out what that age is going to be. Oh, that should be a 2. Okay, Aaron is going to do all the odd numbered cells. So that way, that means, Omar, you will be doing the even number ones. All righty, perfect. All right, very good, Cameron and Danny. I can see you guys are getting your calculations for all ages done. Now remember that mode for the all ages were 2 numbers. So make sure you accommodate for both, because that was a multimodal set. So make sure you have both those modes for all ages.
How do you put all the ages like numbers in order again?
I basically opened up a blank sheet, copied all the 45 ages, and then you do the sort option at the top of the column.
Okay, thank you.
Yeah, you're welcome. Yeah, because remember, if you try to sort it on your template, it just messes up the whole design. So that's why you always want to open up a blank sheet if you're going to sort it from smallest to largest. I'll actually delete the extra sheet since we're not gonna have, sorry, didn't mean to duplicate it, delete it. Alrighty, very good. I can see you starting entering your samples there. Aaron, so very good on that. Group 2, I'm not sure where you guys are at. I'm not seeing. I can definitely see you trying to fill up the all ages section of it. And yeah, getting those samples will take a little bit of time because, we have to come up with the positions in the random number generator and then match those to the ages in our table. So that will take just a little bit of time to get through. Okay, very good, Aaron. Looks like you got your first sample going. Very nice. And looks like Cameron, you're working on the sample there. Perfect. So yeah, once you're done with the all ages calculation, make sure you start working on your samples, because that's going to be, like I said, that one's the one that will take the most amount of time. You can almost do a copy paste since I've already shown you how to do those calculations. So whatever you are comfortable with there, guys. All right, looks like Aaron, you're almost done with your second sample there. Okay, Cameron, I see your first sample is done. I'm not seeing what Christopher or Danny, sorry, and Omar, you guys are doing. I'm not seeing. So I think it's Danny, there's not an age of 45 in our age groups there. So make sure you are, using the correct ages over here. All right, there you are, Omar. I see you're starting to enter your ages in there. Now, if you think it would make it easier, what you can do is copy just the ages, starting at 57 all the way down to 78 on a blank page, but don't rearrange it from smallest to largest, right? Just copy the ages. So that way, if you start at the very top corner, then age one is age one, age two is age two. So that way you don't have to worry about, how many times I need to add like one, two, three to it. So you can kind of do, just take the ages 57 all the way down to 78 and just paste it, but don't reorder it, don't rearrange it. And that way you can get age one, age two, age three. You can do it that way if you think that makes it easier. All right, looks like Cameron, you're on your third sample, as is Aaron. Okay, looks like Danny, you got your first sample in. Very good, Aaron. You're on your fourth one, as is Cameron. Very nice. Danny, looks like you're starting your third sample set. Very good, Emily. Yeah, very good. Looks like Aaron, you are on your last set. Cameron, you too. And Danny, looks like you are also on your last set. Okay, very good progress, Omar. Very nice. All right, so Cameron, it looks like you did the last 5 sets, right? 6 through 10? Yeah, okay. So of course, Danny, you are doing the first 5 samples then. So that way I can just make sure I keep track of which samples were whose. Very good. So again, guys, remember as you are calculating your mode, be careful if you're using the multi-mode formula, because if you have multiple modes, it puts it vertically down in the cell. So you may have to do that on the side and then bring your numbers in and type them in into the box where the mode is. Now, if you only have a single mode, that's not going to be a problem. And then every now and then, I think it gives you a NA or something like that if you do not have a mode. Like you used the formula and typed it in and it may give you like an error message. That means you actually did not have a mode in your data set. So that's always a possibility. Alrighty, guys. So those of you who are finishing up, you can go ahead and finish up your calculations, but since we are at 4:05, we can pick this up next class. I will obviously be saving this spreadsheet so we can pick up the calculations next time since you were not able to get it all done today. And then we'll actually get into the calculations of dispersion next time. So we'll then be able to complete the range and the standard deviation process. So then you will kind of see how the central tendency and the dispersion will work together, okay? So if you want to finish the calculations you're working on, that's fine. And if not, like I said, we can pick this up next class, which would be on Monday, okay? Just don't forget that chapter 2 is also due on Monday at 2:30 p.m. So please make sure you get those chapter 2 homework assignments done, okay? All right, guys, be safe, be careful, and I will see you guys next week. Have a good weekend, everyone. Be careful. Bye-bye.
Audio.
Adios. Bye-bye.
Have a good one, miss.
Yeah, you too.